You know, when you're sorting through old papers, things look similar at a glance. These two equations? They look like siblings, but they behave like strangers. If you treat them the same, you'll end up with a mess. Let's sort them out. Look at the first equation. We're using the formula for the sum of a geometric series. This is a series where each term is the previous one multiplied by 7. In this case, our first term, a, is 7, and the common ratio, r, is also 7. So our equation becomes 7 times 7 to the power of n minus 1, all over 6, equals 2,800. We multiply both sides by 6, and then divide both sides by 7. This leaves us with 7 to the power of n minus 1 equals 2,400, which gives us 7 to the power of n equals 2,401. 2,401 is actually a power of 7, specifically 7 to the power of 4. And we have our first answer, n equals 4. Now let's move on to the second equation. When we multiply powers with the same base, we add their exponents. Since the bases are both 7, we can focus entirely on the exponents. To find the sum of numbers from 1 to n, we use the Gauss sum formula. N times n plus 1, divided by 2. We could also use the formula for the sum of an arithmetic series. In this formula, n represents the total number of terms being added. a1 is the first term, and an is the last term in the sequence. We multiply both sides by 2, and we are left with n times n plus 1 equals 56. We could solve this as a quadratic equation, or we can speed things up a bit. If we rewrite 56 as 7 times 8, and since n needs to be positive, it's easy to see that n equals 7, and n plus 1 is 8. So, there is our second answer. Two similar problems, two different rules. It just goes to show how much one little sign can change the whole approach. If you liked this video, you can find more treasures in the attic by subscribing. Until next time, take care of the logic and the beauty will follow. Enjoy the rest of your day.